our next, I guess, trig topic or topic in this class involves law of sines and law of cosines. So I want to look at law of sines because I want to help you get these correct. Okay. First of all, the processes that you did for right triangles do not work for what we call oblique triangles. And so when I say oblique triangles, I mean angles that do not have a right angle, triangles that do not have a right angle. So you cannot use Pythagorean theorem. You cannot use, opposite, adjacent, hypotenuse. Okay, it's a different process. So here is the law of sines. Now, there are several instances where we can use the law of sines and where we can't. But what I want you to remember is that in order to use the law of sines, first of all, you got to know at least one angle and the side opposite an angle. Now, judging on the midterms, some of you all, I don't think, understand, the difference between an adjacent angle and an opposite angle, sides and stuff like that. If angle A is my angle I'm looking at, remember the angle is the inside. This is my side. This side is opposite A, okay? Because the adjacent sides help form angle A. So opposite, if you draw an arrow from the angle, out of the angle, it's going to hit the opposite side. So please try to figure out a way to understand what's opposite. And that should help you. Now, we have law of sines set up in a proportion. So, in other words, it doesn't matter, whether I use this proportion, this proportion, this proportion. They're all just equal. So I'm choosing two at a time is what I'm trying to say. So let's just say for an example, and right now I just want you to work on using your calculator. This is what this is all about, is making sure you understand your calculator, how to use your calculator. So let's say this here is 40 degrees. Let's say this side here is, for all practical purposes, 10 centimeters. Let's say this angle is 80 degrees. And I want to know side B. So I know angle A and side A, so I'm definitely choosing this. And I want to find side B, so I'm going to set it equal to that. So what I'm going to do is I'm going to set up sine A over side, so sine of the angle over the length of the side equals sine of the angle over length of the side. Now, you're going to be cross multiplying. So I can substitute sine 40 over 10 equals sine 80 over B. So basically what you're going to be doing is you're going to be taking 10 times the sine of 80, not 80. You got to make sure you do sine of 80. That's how trigonometry works. Divided by sine 40. Now, to make this easier on yourself, and here's another area where I saw people messing up, and you shouldn't be messing up because this is just punching this into your calculator. So it's possible that your calculator is set in radian mode and not degree mode. So if I'm getting sine 40, I should be getting 0.6428 rounded over 10 equals 80 sine 80, which is 0.9848 over B. Now, I'm going to give you a second here because I want you to cross multiply and solve for B. Okay? I want you to take 10 times this equals this times b. Don't let the decimals fool you. They treat the same as regular numbers. They're just decimals. And make sure you can understand how to get through this. If you're having trouble getting these, then it could be you're choosing the wrong sign. Don't choose sine -1. It's just sine because I know the angle. Trying to think of all the areas where we have trouble. If you're getting a, let me see, let me put this in radian mode and see what I get here. Yeah, if you're getting a like 0.745 instead of 0.64, that's that you're in radian mode. How do I know that? Well, on this calculator, I've got degrees and radians. So I press it up here till it says, let me put this up here, till it says degree, right up here. Okay. If you're using the graphing calculator, go to your mode button, but just make sure your calculator's in degree mode. So I'll give you a second to solve that. Okay, so I cross multiply. So I get 0.6428b equals 10 times this is 9.848. So b is 9.848 divided by 0.6428. So b is 15.3. So I'm hoping, and I'm pretty sure in this section, they just ask you to round to like the tenths place or 2 decimal places. So, you know, if you don't know how to round, you can Google that. We do have rounding issues, some of us. So, you know, look that up. I mean, it's not that hard of a process. It's probably you're missing one, you know, small tidbit or, you know, something like that. So just Google it up. But that's the tenths place. That's 1 decimal place. So I get 15.3 is B, okay? So B is 15.3 centimeters. Now, angle C, well, all angles in a triangle add up to be 180 degrees. So 80 and 40 is 120. So C is 60. So if I want to find side C, well, I can use either this ratio or this ratio. It doesn't really matter, but I know I got to use that ratio. So I'm just going to go with sine A over A is sine C over C. Okay. Sine 40 over 10 is sine 60 over C. So again, set it up. Make these values decimals. Do not divide by 10. You're just making it harder on yourself. I already know this is 0.6428 over 10, and then I do sine 60, 0.866. Why am I carrying these out to 3 and 4 decimal places? Because it's going to make it more accurate, and you're not going to be counted off for missing it by 2 or 3 hundredths. Because when you're building things, bridges, possibly homes, you know, if you get off a 1/10 of a degree at the beginning, it's not that big a deal. But once you carry that out 100 feet, it's a real big deal. So we like to carry things out, especially if you're machining lots of things, okay? So again, cross multiply and solve. Okay, I took 10 times 0.866 to get 8.66. Now C is going to be 8.66 divided by 0.6428. And I get 13.47, which if I round it to 1 decimal place is 13.5. Okay, so that's what C is. And it holds true because the smallest angle should be opposite the shortest side. And 40 is opposite 10, 60 is opposite 13.5, and 80 is opposite 15.3. Okay, so that's an example on, how to set up these ratios and then making sure you cross multiply correctly.